Hey QED coders, this is Michael. I wanted to talk to you today about something that you should avoid, and that of course is the async void set of keywords. Now async is great, void is fine, but put them together, that's something that you should avoid. There's a great blog by John Thierry, I believe is the pronunciation, where he talks about async void and how you should remove it. So he summarizes here. Why is async void bad? Well, it generates compiler warnings, and it does that for a reason. You want to remove those. But here, point number 2 is the true reason. If an exception is uncaught inside of an async void method, then your application is dead. So this is a pattern to avoid. Well, how do we get here in the first place? Let's tie this all back to the thing that we talk about on this channel all the time, Janaga. Here we have the DWS application, and it is saving a yard. And so we're going to call Janaga client.fact. In fact, we're going to call it 3 times so far. There's going to be even more things that we want to save when the user clicks the save button. And Janaga client.fact is asynchronous, so you have to await it in order to make sure that it succeeds. If it fails for some reason, then awaiting it will cause it to throw the exception. If you fail to await it, then if something bad happens, the exception won't come back to your code. It'll go off somewhere else, somewhere in the operating system, or in the basically just crash your app, and you don't want that to happen. So you definitely want to await things, especially because here you get the result, and now you can use that result to create more facts. And so in order to await, we have to mark the method as async. And in order to make it async, we have to return a task. And then if we continue up the stack here to the view model, to the view, that was the view model we were just looking at, right here, we are calling save. Well, because it returns a task, we can't just not await it. We have to await it. Otherwise, where's the exception going to go? It's going to crash our application. So we await it. And then that means that this method needs to be async. And if it's async, then it means it needs to return, it's not returning a task. The compiler will allow us to not return anything, but if we return something, it has to be a task. So this basically means that whoever is calling save click cannot await it. Now, who's calling save click? This is an event. It is called within the XAML. So here is our task dialog XAML. And here is our save button. We've got click, save click. So this is generating code that will call save click. And that code doesn't know about async. It's expecting to call void methods. So here we are capturing the exception, so we know that the exception is not going to get thrown from this method. Here he has generalized that and turned that into a fire and forget safe async method. And so now this is the one and only place where he has hidden async void. And he's hidden it in a way that now it's safe. It is not going to throw an exception. The repository async await best practices basically wraps this up and turns it into a NuGet package. So using this, you can install async await best practices into your application, call safe fire and forget, and then on exception, do this, whatever you need to do with that exception. Now, I want to completely own this this pattern myself. So rather than bringing in that library, I'm going to re-implement it myself. And the reason is that I also want to decide what to do with those exceptions, and I want to standardize on that. And that's something that the library can't do for me. I'm going to make that decision in my application. Now, in this case, the await is not the last thing that happens. We continue. We do more stuff. One of the things that Jean Thirier talks about in the post is that if we can move the await to the very last thing, then we've got this option. So yeah, we move things around, and so what we want to do is get the await to the end of the method. So one way to do that is just simply extract the method. We'll call this handle save. Boom, now we've got handle save, and now we have await at the end of this method. It just calls handle save. It awaits it, and we're done. Which means now, if we go to the handle save.continue with, and we have if t is faulted, you can see that the extension method that the library gives you is, it really just boils down to these 2 lines of code. We'll work through the entire solution before we codify that into something reusable. So here we are. We are handling save. We are handling the exception, should an exception happen. And now, this way of handling the exception is not really the way that I want to do it. I don't want a message box popping up in the user's face. What are some of the better ways to handle messages in a WPF application? Well, those better ways might be to use another library. For example, we might use this library, Notifications WPF. I mean, look at it. It's beautiful. It's gorgeous. Let's go ahead and bring this one in. I'm going to install this package. And now have that package installed. Let's see how we can use it. Now, instead of calling messagebox.show, we need to call notificationmanager.show. We'll copy this code in. So here is the notification. I'm going to modify this error while saving, and the message shall be t.exception. I'm comfortable with that assertion because I know it is faulted and therefore the exception should not be null. So I can do the message. And we will call this error. Now, just to make sure that that this actually works, let's change this a bit. So I'm going to await task.delay for 400 milliseconds. And then I'm going to throw a new exception. Give it a nice little name and comment out the rest of it. All right, so let's see what's going to happen when we press save. You'll see this little window right over here. That is the toast notification area of my other monitor. So when I hit save, we'll see, boom, we get the error. Awesome. Hit it again, boom, another error appears. After some time, disappears. Really nice toast notifications. Good job. Good job. Nice library. And so you can see we did that by creating a notification manager and then calling notification manager show. So now I'm starting to see a block of reusable code here. This is something that I want to do in every handler. I want to have some kind of asynchronous method, and then I want to do all of this stuff. In fact, I even want to extract the notification manager so I'm not creating it every time, but instead I just have a singleton. So if I were to replace this with some object that I passed in, what would the interface of that object look like? What would I want to do? So now this is me making a wish and writing a contract. I wish the application looked something like this. So this would be the command handler, for example. I call it command handler. And then I say, boom, handle. And then I pass in handle save. I don't know. What do you think? Is that the right way to name things? It's not really a command handler. The handler is this method, handle save. Maybe the command executor? That's kind of a strange word. Processor? Sure. Process. Why be so pretentious? It's just run. Run it. Command processor run. We'll go with that. Come up with your own names. So I want to be able to pass something in that matches that signature and does all of this. So let's go ahead and create something. Yep, there's our command processor. It's okay for it to be internal. And then let's make sure that we get one of those things. So this new task dialog, it'll take the view model and the command processor. And we will create and assign a read-only field for that. Very good. So now I've got command processor and I want to call run. So let's generate that method. And that is going to be an internal void. I don't like internal for these. It's public to the consumers, but the class itself is internal to the assembly. That's fine. That's good. So we're not going to call it handle save. We're just going to call it handle. So that's a function taking a task and returning nothing. Great. Perfect. Now, what is it going to do? It's going to do all this. So we've got our handle function. We're going to continue with, I'm going to call the function. There we go. Now I've got the task. And then I can bring in notification manager. Very good. Okay, so that's my command processor, and I can get rid of this stuff. Very good. And so I should see that it still works. Let's give it a shot. No! New task dialog. Oh, yes, of course, I need to... this is public, so this needs to be public. Okay, fine. And get rid of those usings. Okay. Now when I try to construct it, I'm going to run into problems because I need a command processor. Pass that in, and now it should be good. This, by the way, is eventually going to be replaced with IOC, but for right now, it's just creating a bunch of stuff. I like to see how things are going to come together first. All right, so we're going to create a new task. We're going to hit save and boom, error. Perfect. Okay. All right. Interesting that it doesn't shut down. I wonder. I'm just going to run the app and then shut it down. And now it shuts down. I think that the, if I go to the command processor, I think that the notification manager needs to be shut down. It probably has some start and stop kind of stuff going on. And so that's a good reason that we should now do this next thing, where we take this notification manager and we extract it. This should now be injected into the command processor. All right, now it's being injected, which means right here, when I create one, I need to create a command processor or a notification manager. Pass that in. All right, that's all good. Now we've injected it, so the command processor is always going to use the same one. It's not going to create a new one every time. And so when I create this new task, I can hit save. Boom. I get the error, get another error. That's all good. So those things are working nicely. Now let's take a step back and see where we are. New task dialog takes a command processor, and now it can call command processor.run. And now we no longer have async void. We have avoided async void. In fact, we can even go one step further, and we can say async and no parameters, and we can have it all right here. So this is a way that we can declare an async without it leaking out and becoming async here. So I can await inside of this thing because I'm doing something with that task. Run is calling this method and then giving me doing something with the task. I did a little bit of research and I found why the application wasn't shutting down. This is the notifications library that I added, notifications.wpf. And in fact, there is an open issue about this exact problem right here. If used, process can't be exited. And yeah, after a long conversation, they say, you know what? This library hasn't been maintained and they haven't fixed this issue. There's this other one, this fork, notification.wpf. This one is maintained. I have gone ahead and updated the library to use that one instead. And that's when I ran into another issue. Let me show you what this other issue is all about. So let me bring my notification window back on. It's over there. There it is. So let's go ahead and run this. When we hit the button, you expect to see a notification pop up over here, right? Boom. Oh no. The exception says must create dependency source on same thread as dependency object. Basically, this is an exception that happens when you try to manipulate the UI when you're not on the UI thread. There's a problem. Okay, the old library would automatically marshal everything to the UI thread. The new library, for some reason, you took that out. But that's okay. It's not really supposed to be that library's responsibility. We're supposed to take care of that. And in fact, I'm the one who got us to the other thread. So I need to fix that. Let me show you what I mean. Yeah, we don't need that window anymore. We'll bring that back in a little bit. But, all right, the problem ends up here in my command processor. Let's take a look at handle. And then if I get called back with faulted, let's check that out and see what happens. All right, now I hit save. So that calls handle, and you can see that I am on the main thread. There's that little yellow arrow right there that tells me that I'm on the main thread. But then I let it run. It's going to throw the exception, and now continue with is going to come back no yellow arrow. It's not on the main thread anymore. We are down here on some worker thread. And the worker thread is not allowed to manipulate the user interface. And so, boom, it throws the exception. That's what the problem is. So, how do we fix it? There are two ways to fix it. One way to solve that is right here, to tell continue with to use the task scheduler from the current synchronization context. So as I call this handle method and I get back the task and I call continue with, I'm still on the UI thread. So I pass in the current synchronization context from that UI thread so that when it gets to the callback, it's going to use that same thread to continue. It's not going to do this by default. And so if I do that, spoiler alert, my little window's coming back, hit save, and where'd you go? Oh, that's weird. That is really weird. I don't know why. But let me pop this over to the other screen and hit save from over here. Yeah, all right. Yeah, there we go. It popped in. That is... Yeah, what was happening is it was showing up on this screen, but you couldn't see it because my big head is in the way. So there we go. Now it puts the toast notification on the same window that the dialog is on, which is pretty cool. The same screen. Okay. All right, so improved library and improved method to continue on the same thread. Now I said there were a couple of ways to solve this problem. This is one way. The other way, you can go away now. The other way is to do what the blog post and the Async best practices library do. And that is instead to do this in a try catch. But now, of course, since we do this, we have to make this async. So we're back to an async void, but it's hidden. There's only one place where async void appears. So maybe that's okay. Just to complete the story, let's run it. I'm going to push the button on this other window so that we can see 1, 2, 3. Boom. There's the error. Okay. Everything is working and there are no exceptions because we're moving from one thread to the other. So if you don't mind async void appearing once in your application, go ahead and do this. It automatically continues on the UI thread, just because of the way that WPF has set up your application. If you don't even want that one async void to appear, then use the current synchronization context in order to resume or continue, and that gets you back to the UI thread that way. So you've got two options. Whichever option you choose, I hope that you will use this to avoid async void and build something awesome.